5.5. This is our last section in chapter 5. And we're going to talk about double angle formulas. All right, so we have our double angle formulas all come from our sum formulas. They are also on your identity sheet. So I'm just going to write them down, and what I want to do is show you quickly where a couple of them come from, and then we're just going to do a couple of examples. So our formulas, the sine of 2u, and this is on your identity sheet, so you can rewrite them if you'd like. I just want to write them up here just so we have them to refer to. Sine of 2u is 2 sine u cosine u. The cosine of 2u. We have several different ways we can write the cosine of 2u. Cosine squared u minus sine squared u. This is also equal to 2 cosine squared u minus 1. And this is also equal to 1 minus 2 sine squared u. So we have 3 different formulas that we can pick from for cosine of 2u. And then the tangent of 2u is 2 tangent u divided by 1 minus tangent squared u. And the reason that we're using these, the reason that these are useful, is a lot of times it's easier to work with our formulas in this form rather than the sine of 2 times an angle. We want to work with just the angles. And sometimes it's easier to work the other way. Sometimes we want the cosine of 2 times an angle or the sine of 2 times an angle. Just makes it easier to work with. So let's take a look at where a couple of these come from, and then we'll do some examples. So let's look at the formula for the sine of 2u. We already have a sum formula. So our sum formula for sine, the sine of u plus v, is sine u cosine v plus sine v cosine u. So this is the sum formula that we've talked about already. Now if u and v, if they're the same angle, so we're going to look at the sine of u plus u. So we're going to use our sum formula, but we're going to put the same angle in there twice. That's going to be the sine of u times the cosine of u. I'm just using this same angle twice, plus the sine of u times the cosine of u. Both of these angles are the same. And this just gives me, I have 2 of these things, so I get 2 sine u cosine u. So that's where this formula comes from. It's just using our sum formula, but using the same angle in there twice. So that's where this comes from. So if you ever forget the formula and you remember the other one, you can figure it out. And let's look at one. We'll do one of these for the cosine, and then the others are very similar. So we have a sum formula for the cosine. Cosine of u plus v. This is the cosine u cosine v minus sine u sine v. This is our sum formula that we've been working with. Now I'm going to put in the same angle twice into this formula, u plus u. So this is going to be cosine u minus sine u, and I get cosine squared u minus sine squared u. And this is cosine of 2u. U plus u is just 2u. And this would be sine of 2u. U plus u is just 2u. So this is where the formula, this first formula for the cosine comes from. We just plug in u twice into our sum formula. Now the other two just come from using the Pythagorean identity for sine squared u, plugging that in here and simplifying. And the third one would come from using the Pythagorean identity for cosine squared u and then simplifying. So it comes from each of these other formulas come from this first one, just using an identity for either sine squared u or cosine squared u and then simplifying. And the formula for tangent of 2u comes from our sum formula for tangent of u plus tangent of v, and I just plug in u twice and simplify. So that's where the formula comes from. All right, questions on where these come from? All right, so let's look at a couple of examples of how we use them. All right, so we want to solve sine of 2x minus cosine of x equals 0. So we want to find the values of x that make this equation true. Well, the first thing that we notice is that here in the sine function I have a 2x, and in the cosine function I have an x. So that gives us a problem. We want the same thing in our sine and our cosine functions. So I'm going to use the formula for sine of 2u. Sine of 2u, I'm just going to put it over here on the side. Sine of 2x equals 2 sine x cosine x. That's from our identity. I'm going to plug that in right there. So I get 2 sine x cosine x minus cosine x equals 0. So now instead of a 2x here, I have just x's. Now for my next step in solving this, what are we going to want to do? Yes. Factor cosine. Cosine is common to both terms, so I'm going to factor. So I get a cosine x times 2 sine x minus 1 equals 0. Now what do? I have two things that multiply to 0. So what's the only way that two things can multiply to 0? One of them has to be 0. So cosine x equals 0, or 2 sine x minus 1 equals, not 1, equals 0. So cosine x, and then we look on our unit circle, where on the unit circle is cosine x equal to 0? X equals pi over 2, and we add multiples of 2 pi plus 2n pi. X equals 3 pi over 2 plus 2n pi. These tell me the values of x where the cosine of that value is 0. Over here we just need to do a little more work. I add 1 to both sides, divide by 2. I get sine x equals 1/2. I look on my unit circle and figure out where the sine of my angle is 1/2. And I see that x equals pi over 6 plus 2n pi, and x equals 5 pi over 6 plus 2n pi. So I have four solutions plus multiples of 2 pi for this equation. Questions on that one? And the reason we had to use our identity is because here in the beginning I had a sine of 2x, and here I had a cosine of x. So I had a 2x in one function and an x in the other function, so that's why we had to use our identity. Everybody clear with that one? All right, let's look at another example. We want to simplify cosine to the fourth x minus sine to the fourth x. So we want to simplify this. Anybody have an idea of how we might want to start? So we had a double angle identity for cosine. So we know we have an identity, so that's a good place to start. Our identity says cosine of 2u equals cosine squared u minus sine squared u. Well, this looks kind of like that. So let me give you a hint, and then we'll see if we can figure out where to go from here. What if I wrote this as cosine squared x squared minus sine squared x squared? Does that help us out at all? What if so let me give you one more hint, other than going away from trigonometry. What if I had x squared minus 4? What's that? Difference of squares. These are both perfect squares. So I have a difference of squares. How would I factor this? X plus 2, x minus 2. Well, here we have two perfect squares also. So I can factor this the same way. So this would be cosine squared x minus sine squared x times cosine squared x plus sine squared x. Exactly the same idea here. Well, what's cosine squared x minus sine squared x? Cosine 2x. What's cosine squared x plus sine squared x? 1. So this equals cosine 2x. This simplifies to cosine 2x. Cosine 2x is way easier to work with than cosine to the fourth x minus sine to the fourth x. And our jumping off point was recognizing that we have this identity that looks kind of like this. Yes? Sine squared x plus cosine squared x, that's one of our Pythagorean identities. Sine squared x plus cosine squared x is always 1. Okay? All right, one last example. And then we are done for the day. Excuse me. we're given that the sine of x equals 12/13 and x is between pi over 2 and pi. So before we even go any further, what does this information, what can we figure out from this information? This sine of x equals 12/13, we can figure out a right triangle. What is it telling us when x is between pi over 2 and pi? It's in the second quadrant. That tells us where our triangle is. So let's, before we even write the rest of the problem, we have a triangle that looks like this. The sine is 12/13. So this is 12 and that side's 13. So we already know this much information. Now let's see what the problem asks us. Find sine 2x, cosine 2x, and tangent 2x. Our identity for sine of 2x, we know that sine 2x equals 2 sine x cosine x. So to find sine of 2x, I need to find the cosine of x. We know that the cosine of 2x equals, and let's pick out a good one to work with. Let me go back here. Cosine of 2u is 1 minus sine squared of u. So to figure out the cosine, I don't even need any other information. I can just use this identity. Cosine of 2u, all I need is a sine of u to figure it out. So that's this third one is what I'm going to use for the cosine. Cosine of 2x is 1 minus 2 sine squared x. So I can just plug numbers in there. And then tangent of 2x, our identity for tangent of 2x is 2 tangent x over 1 minus tangent squared x. So in order to find the tangent of x, we need to find the cosine of x. And in order to find the sine of 2x, we need to find the cosine of x. So from this right triangle, we can find our missing side. Does anybody know right off what this is going to be? Not 8. So let's use the Pythagorean theorem. I just wondered if you recognize the Pythagorean triple. So let's call this, what is it? It's 5. It turns out to be 5. So if we use a Pythagorean theorem here, this side of the triangle turns out to be 5. We can go through it. You could calculate it yourself. Now, in the second quadrant, what am I going to want to put with that 5? A negative. We're in the second quadrant, so x is negative. So I'm going to label that side as negative 5. This is my angle, x. So cosine of x equals minus 5/13. And I can calculate this. This equals 2 times 12/13 times negative 5/13. And I can multiply that all out. And I get minus 120 over 169. So that would be the sine of 2x, minus 120 over 169. Cosine of 2x, I just need to plug in 12/13 for sine of x and square that. So cosine of 2x is 1 minus 2 times 12/13 squared. And if I plug this in and if I calculate everything, square 12/13, this turns out to be minus 119 over 169. What would be an easier way of finding tangent of 2x than plugging into this formula? Because this involves a lot of calculation. Sine over cosine. Tangent to x equals sine 2x over cosine 2x. That's way easier than calculating this. I have the sine of 2x, I have the cosine of 2x, so this equals minus 120 over 169 divided by minus 119 over 169. This is when I divide by a fraction, I multiply by the reciprocal, and this turns out to be, let me write out that step, minus 120 over 169 times 169 over minus 119. These 169s cancel, and I end up with 120 over 119. So that's the tangent of 2x. And that's what our problem asks us to find. The sine of 2x, the cosine of 2x, and the tangent of 2x. We used our right triangle and a couple of identities. Questions on that one? All right, that's everything for today. Homework. I suggest we have almost a half an hour. I suggest that that you work on the homework, that you ask questions, so that you're actually practicing with this stuff before you see it on the test.
Oh, the howler. Look at that.